Welcome to Learn Math with Bola, and today I'll be sharing a tutorial about introduction to indices. In this video, we'll be learning together about indices, exponents. We'll be talking about the law of indices. We'll look at the law of indices one after the other, and we would also look at examples and solve some very basic indices questions. Let's learn together. So what is indices? Indices, or an index. Indices is the plural of index or exponent. In mathematics, is a number that indicates how many times a base number is to be multiplied by itself. So what am I saying in essence? That if you have an expression and the expression is a raised to power n, a is the base and n is the index or exponent. So the number a, which is a natural number or an integer, is the base and n is the index or exponent. Now the exponent tells you how many times to multiply the base by itself. So from this explanation, indices and exponents means the same thing. So the index is the exponent. For example, 2 raised to power 3 means multiply 2 by itself 3 times. So you have 2 raised to power 3 will be equal to 2 times 2 times 2, which is what? 8. Now the laws of indices. Let's look at the laws of indices one after the other. So the laws of indices are the laws that guide questions on indices and how you can approach questions on indices. We have the multiplication law, and the multiplication law of indices says when multiplying two powers with the same base, add the exponents. So what we do is that when you have numbers that have the same base that are multiplying each other, let me say index numbers or indices, where you have two numbers multiplying each other and they have the same base, what you just have to do is add their powers together. So the example is 2 raised to power 3 times 2 raised to power 4. The base number in this example is 2. 2 on the first side, you have 2 on the other side. So you simply have to add their powers together, and then you have 2 raised to power 7, which will give us 128. Let me explain again. The multiplication law says that when multiplying two numbers with the same base, add the exponents. So like we established already, that the index number, that is the number where that is the base is raised to the power, is the exponent. So when you have a raised to power m times a raised to power n, then you would have it as a raised to power m plus n. And this laws follows. In this situation, the law follows only if your a is at the same number. So in the example, you have 2 raised to power 3 times 2 raised to power 4 equal to 2 raised to power 3 plus 4, and that gives us 2 raised to power 7, which is 128. Let's go to the next law, that is the division law. And the division law says when dividing two powers with the same base, subtract the exponent. So this is the rule: a raised to power m divided by a raised to power n is equal to a raised to power m minus n. So when you have a raised to power m divided by a raised to power n will be equal to a raised to power m minus n. So let's take an example. You have 5 raised to power 8 divided by 5 raised to power 4 will give us 5 raised to power 8 minus 4. So we can also see that this law will also follow only if your base, that means your a's, are the same number. So we have 5 raised to power 4 is equal to, so we have 5 raised to power 8 minus 4 rather is equal to 5 raised to power 4, and that is 625. Then we have the power of power law. The power of power law that says that when raising a power to another power, multiply the exponents. So for this question, for this law rather, you have, if you have open brackets a raised to power m and close brackets, then everything is now raised to the power of n. All you have to do is just multiply your m and your n together. Let's take an example. We have 2 raised to power 2 all in brackets 3. So we have to open the brackets to have 2 raised to power 2 times 3, and that is 2 raised to power 6. Then we can now multiply 2 in 6 places to get 64. Let me take this again. The power of power law says that when raising a number, a power rather, to another power, multiply the exponent. We have established already that the exponent is the number that you are raising the base number to the power, that is the index. So we have a raised to power m, everything in brackets, raised to power n will be equal to a raised to power m times n. So 2 raised to power 2 in brackets, that means 2 raised to power 2 in brackets raised to power 3 will be equal to 2 raised to power 2 times 3, and 2 times 3 will give us 6. So we have 2 raised to power 6 equal to 64. Let's go to the fourth law, that is the power of product. When raising a product to a power, apply the exponents to each factor. Let's see the law so that we can understand easily that when you have a times b are in brackets raised to power m, then it is the same thing as a raised to power m times b raised to power m. Now you have two numbers which are different base. You have a separately, b is a different number. They are not the same number, and they can be the same number. They can also be the same number. So you have a times b raised to power m, that is everything, will give us a raised to power m times b raised to power m. So we have 2 times 5 into brackets raised to power 2 will give you 2 raised to power 2 times 5 raised to power 2. I know for some students you are wondering what is the use of this power of products law. In your mind you are feeling like, why not say 2 times 5 equal to 10, then 10 raised to power 2 is straightforward. This law is here because sometimes you may not be dealing with natural numbers. For this kind of expression, you can have something like 2a times 5b, then 2a times 5b c something, and then you have everything raised to power 2, and you are wondering how do you go about it, especially when those numbers in brackets also have their individual powers. So to make the work easier and faster, that is why this product rule follows. And when you have questions like that that are complex, it tends to help you solve it easily and reduces the error. So we have 2 raised to power 2 is 4, and 5 raised to power 2 is 25. So 4 times 5 is 100. So if we had done 2 times 5 10, then 10 raised to power 2 we would have also gotten 100. So that tells you that the law follows. Both sides of the equation are still equal. Fifth law, the power of quotient. When raising a quotient to a power, apply the exponent to the numerator and the denominator. Quotient is a fraction. So we have a fraction. So we are now dealing with indices that are fraction based here. So when you have a over a divided by b, everything in brackets raised to power m, so you can apply the power to the numerator separately and also the denominator separately to have a raised to power m over b raised to power m. Let's take an example. 2 over 5, everything in brackets raised to power 3 is the same thing as 2 raised to power 3 divided by 5 raised to power 3. So 2 raised to power 3 is 8 and 5 raised to power 3 is 125. Then we have the zero exponent law. So that's from the word we can get that when you have an exponent that is 0, so you have any non-zero number raised to the power of 0 is 1. So you have any number, let it that number be as long as the number of people in the world. As long as it is raised to the power of 0, the answer is 1. So you have a raised to power 0 equal to 1. So 5 raised to power 0 will be equal to 1. That's the law, as simple as that. Then the seventh law, which is the final law, negative exponent law. So we can, from the word, we can deduce that when you have an exponent that is a negative number. So the law says a negative exponent represents the reciprocal of the base raised to the opposite positive exponent. Don't be fooled by all the grammar. Let's take it slow. So this is the illustration of what we are saying. When you have a raised to power minus n, it simply means that you have 1 over a raised to power n. So we are having a raised to power minus n to show you that your a raised to power n is the denominator and not the numerator. So all you have to do is put your a raised to power n as a denominator and then you put 1 as a numerator, depending on if your a raised to power minus n has a number before. If it has a number before or even after, then you can always use that number as a numerator instead of 1. So we have 5 raised to power minus 2 is equal to 1 over 5 raised to power 2, and that is 1 over 25. So those are the laws of indices, and this is a quick recap of it. You have a raised to power m divided by a raised to power n is the same thing as a raised to power m minus n. Then your a minus n, that is a raised to power minus n, is equal to 1 over a raised to power n. A raised to power 0 is equal to 1. A raised to power m times a raised to power n is the same thing as a raised to power m plus n. And you have a raised to power m, everything in brackets, raised to power n is equal to a raised to power m times n. Then you have a times b, everything in brackets, raised to power m is the same thing as a raised to power m times b raised to power m. Then you have a divided by b, everything in brackets, raised to power m is equal to a raised to power m over b raised to power m. So these are the laws, 7 laws of indices. And sometimes you can have questions where 2-3 of these laws can be in one, but we are not going to do that now. Let's go to examples. Let's solve some basic examples because we are dealing with introduction to indices. So let's solve some basic examples. You have simplified 2 raised to power 3 times 2 raised to power 4. This is which law? Your guess is right, as good as mine. This is the multiplication law. So what do? The two of them have the base number 2. Both have base number 2. So the multiplication law says a raised to power m times a raised to power n is equal to a raised to power m plus n. And from my equation, a is 2, m is 3, and n is 4. So just like you are using a formula, let's replace each of the letters with those numbers to have 2 raised to power 3 plus 4, and then you have 2 raised to power 7, which will give us 128. So it's as simple as that. If you know the law, all you need to do is identify those letters. Which letter is this number, which letter is this number, then just replace them, and it makes your work faster. So we have simplify 5 raised to power 6 divided by 5 raised to power 2. This follows the division law. So let's write out the division law. You have a raised to power m divided by a raised to power n is equal to a raised to power m minus n. So our a in this sense is 5, our m is 6, and our n is 2. So what do? We only have to replace those letters. So I have something like this: 5 raised to power 6 minus 2. 6 minus 2 is 4. So we have 5 raised to power 4, and that is 625. The next example says 3 raised to power 2, everything into brackets 3. So the law here is the power of power law. The power is raised to another power. So we have a raised to power m, everything into brackets, raised to power n is equal to a raised to power m times n. So our a is 3, our m is 2, n is 3. Let's expand. So this will give us 3 raised to power 2 times 3. Then you have 3 raised to power 6, and that is 729. So we have 7 raised to power minus 2. The next question now: 7 raised to power minus 2, this is what? Yes, this is the inverse. This is where we spoke about the negative exponent. So you have a raised to power minus n is equal to 1 over a raised to power n. So our a is 7, our n is 2. So you have 1 over 7 raised to power 2, and that is 1 over 49. So we have simplified 4 raised to power 0, and this is what? The zero exponent law. So the zero exponent law, and that says that a raised to power 0 is 1. So our a here is 4. So let's replace our a by 4. We have 4 raised to power 0 equal to 1. As simple as that. So that's all the examples I've got today, and don't forget to follow this channel for more tutorials, and if you're on Facebook, follow this page for more tutorials. And thank you for watching this. Don't forget to follow us on all social media platforms. Kindly subscribe to this channel, like this video, and share with your friends. Thank you for watching once again. Bye.